Okay, welcome back. So where we are now is we analyze the forces of our uh, transmission shaft system. Okay, so this is before the break. This is the most difficult part. Okay, other than that, everything will be smooth sailing. It's not get that difficult. Once the direction is right, yeah, okay. Okay, when the direction you don't get it right, that's where problem will occur. Okay, so now. So we know now, probably now is a while ago now. I don't think you all can remember, but let's look. So we know that power input. Let me get the diagram. Okay, I need this diagram. Okay, so we're from this diagram. So we know that power input by motor 30 kilowatt. Okay. So when it's 30 kilowatt, we know that gear E, which is the driver, it will give what? 30 kilowatt. Okay. Input. So we look at gear D, which is the driven. It's going to take gear D. Let me recap. It's going to take, based on the question. Hold on. Where is my question now? Gear D. My question gone missing. Gear D is going to take gear. Hold on, 20 kilowatt at gear G and 10. Okay, so this is 10 kilowatt output. And at gear C, which is also the driven, is going to take out 20 kilowatt output. And the rotation at gear E is equal to the rotation at gear D is equal to the rotation at gear C, and we are running at 400 and 400 and I can't read from my printout now. 480 RPM. Is it 480? Let me see. The 480 RPM. Okay. So there's one formula to relate, okay, power power relate power to torque and then to force, right? So we know that power is equal to 2 pi nt divided by 60, where n is the rotational speed So this is in RPM, revolution per minute. T is the torque. And then we know from the torque is equal to power, force times radius. Okay, force multiplied by radius. Right, then we can get the force. Okay, so from the force, okay, bending moment can be calculated. Okay, so from here we can know our normal stress, right? So we're going to find normal stress is equal to m y over or m about the y-axis I y z, or mz over I z multiplied by y. Okay, so now let's look at power first. Okay, let's look at power first. So I will this diagram is no good for me now. So we know the power. We're going to look at gear C or gear, sorry, we're going to look at gear E first. Okay, we're looking at gear E. Okay, so at gear E, we know that the power is equal to 30 kilowatt. Okay, so power is equal to 2 pi nt about 60. So this is equal to 30 times 10 to the power 3 is equal to 2 multiplied by pi. So n is going at 480 t and then 60. So this is at point at gear E. So the torque at gear E is equal to 60 times by 30 power 3 to the power 2 right, shift 5 to the power 480. So it's equal to 596.8 Newton meter. And from here we can calculate E, force at E, right? So the force at E, we'll look at EY will be equal to 596.8 divided by the radius, which is 0.16 divided by 2. Okay, let me, it's so messy, I do apologize. So 596.8 divided by 0.16 divided by 2. So 596.8 divided by 0.16 by 2. So it's equal to, oh no, 0.16 is already the radius. I do apologize. Okay, so 5.8 divided by 0.16 is equal to 3730 Newton. Okay, so we know that E at Y is equal to 3730. Right. Then the next one, we want to find the gear at point D. Right, the gear at D. Okay. So gear at D. The power is 10 kilowatt. Right. So same formula we apply 10 times 10 to the power 3 is equal to 2 pi 480, the top at point D, divided by 60. Right, so the top at point D is equal to 10 power 3 times 60 divided by 2 divided shift pi divided by 480. So it's 198. Yeah, I get 198. Wait, did I do 10 power of 3 times 60 divided by 2 by shift pi divided by 480? It's got 198.9 Newton meter. Okay, so let me check something. I'm getting, so this is at point D. Yep. Okay. So point D, we are calculating, at the end of the day, we are calculating for D. Oh, I do apologize. This is DZ. Okay, I got this wrong. Means when I got this wrong, I do apologize. Okay, this is also wrong. Yeah. So probably somewhere around here. Yeah. So this is DZ. Okay. So now we know that DZ. So DZ is equal to 198.9 divided by the radius, which is 0.08. So 198.9 divided by 0.08 is equal to 2486. Okay, 2486 Newton. Okay, so we know that this is equal to 2486 Newton. And then next we go into CZ. All right, so you can see that this is very repetitive, where power is equal to 20 kilowatt. As I said, this is the easy part already, right? Once you finish the analysis, later on I'll show you where it gets challenging again. Okay, not impossible, but more challenging. Okay, top at C, so divide by 60. So the top at point C is equal to 20 power 3 times 60 divided by 2 divided shift pi divided by 480 is equal to 397.9. And then the force in the Z direction is equal to 397.9 divided by 0.06. So those are the radiuses, okay? 397.9 divided by 0.06 is equal to 6632. Okay, so we know that this is equal to 6632 Newton. Okay, so once the forces are done, once you know the direction, the rest are more straightforward. Okay, so what we are going to do next is we are going to do static analysis. Okay, I repeat again, we are going to do static analysis. Okay, so what we are going to find here. Okay, so do I have spaces here? Yep. Okay, so I'm going to copy this entire diagram again. Oh, my bad. Okay, so let me hold on. It's me, okay? It's not. I was being stupid just now. Okay, I will. Okay, so what we are we're going to do now is we are going to find the forces. Okay, so we are going to again view